For decades, we have allocated billions of dollars to a single pursuit, determining if biological life exists beyond our own atmosphere. The expectation was that by capturing our closest neighbors on high-resolution film, our technology would provide a definitive yes or no regarding the existence of extraterrestrial life. This chart shows the current scale of human exploration. We have mapped roughly 1% of the known universe, yet even within that sliver, here in our own solar system, the data we collect is often difficult to reconcile with our existing models. Instead of finding only inert, predictable terrain, the official archives from NASA contain a series of visual anomalies that sit in the tension between planetary science and unexplained phenomena. These photographs suggest that the debris on these worlds requires an explanation that standard geology has yet to provide. This is the Moon, sitting 384,000 kilometers away. It is the only celestial body humans have physically explored. Reaching it was the defining feat of the 20th century. In 1968, the Apollo 8 mission completed a 70-hour journey to capture the first perspective of the Earth rising over the lunar horizon. 1 year later, Apollo 11 landed. Neil Armstrong's mission proved the Moon lacked an atmosphere and possessed significantly lower gravity than Earth, allowing his footprints to remain preserved in the dust for decades. This topographical map identifies a massive anomaly on the Moon's far side. It covers 43,000 square kilometers, an area that appears to be composed entirely of metal, distinct from the surrounding lunar soil. While the metal deposit is a geological puzzle, independent researchers point to a different concern: small, building-like structures appearing in official NASA photos. In some instances, when the agency updated those specific image files, the structures were no longer present. We have actual samples of lunar dust in vaults on Earth, but the existence of these disappearing structures suggests that our maps of this neighbor are far from complete. Visiting Mars is a complex logistical challenge. Because Earth and Mars orbit the Sun at different speeds, the distance between them constantly shifts. At their closest, they are 62 million kilometers apart. At opposite sides, that gap grows to 400 million kilometers. Bridging that gap requires a 7-month flight. The difficulty of landing is evidenced by the mission history. Out of 21 rovers sent to the Martian surface, 17 have crashed during the descent. The data transmitted by successful rovers confirms that billions of years ago, Mars possessed a thick, Earth-like atmosphere and vast surface oceans. Knowing that Mars once had the conditions necessary for life changes how we must interpret the specific objects found on its surface today. To study that surface, we rely on the $2.8 billion Curiosity rover, which has sent thousands of high-definition images back to Earth. Some of these images contain stone formations that mirror the layout and geometry of the pyramids of Giza. Other photos show shapes that appear biological in origin. In 2015, Curiosity photographed a structure resembling an ancient bone, and in 2016, a shape that matches the proportions of a skull was found resting in the dirt. The rover has also captured technological curiosities, including a dust-covered object with the specific symmetrical features of a mechanical engine. Perhaps the most difficult to explain is a 2014 photograph showing a concentrated, artificial-looking beam of light emitting from a rock crevice. These visual anomalies present a choice. We are either looking at a series of highly specific geological coincidences, or we are seeing the surface evidence of a buried presence. This leaves us with two competing interpretations. NASA categorizes these shapes as pareidolia, the brain's tendency to find familiar patterns in random terrain. Conversely, researchers argue these are the decaying remnants of a civilization that once thrived in the Martian oceans. Whether these are genuine artifacts or oddly shaped rocks, they highlight the fact that we have only begun to understand the history of our own solar system. Upcoming missions will function as forensic expeditions into a cosmic crime scene, seeking answers that have remained hidden for billions of years.